Hello students, in 12th class I have told you about the half wave rectifier and the full wave rectifier. Today I will also tell you about the full wave rectifier, but this is not like that you have studied in the previous lecture. This is the bridge rectifier. Full wave bridge rectifier. You saw that in half wave rectifier there is one diode which is used. In case of full wave rectifier the two diodes are used, but here in this bridge rectifier the four diodes are used. Now circuit diagram of this one that I am telling you to this. This is the AC means. These are the induction lines. Here. This is RL, the load resistance. And now we can increase to this up to this level. This is diode D1, this is your D2, this is D3, this is D4. So this bridge is just like the Wheatstone bridge. This is the primary coil, this is secondary coil, this is A, this is your B, this is your X, P, Q, and this is now Y. So now this is the current flows like this. This is the bridge rectifier. It is just like the bridge on the river. So that is can be held like this one. This is now water flowing, and these are the two sides of the bridge, and that they make this one. So this is a bridge. Here four diodes are used. The secondary coil. S of transformer. Is connected to a bridge rectifier having 4 diodes. D1, D2, D3 and D4 as shown in the figure. So the action will be just like the input is like this. This is 0, this is input, and it is like this. This is time t, and we are having the output zero. This is V naught, so we will have this is the input, this is the output. So this is input, this is output. So this is what, this is a positive half cycle, then negative half cycle, then positive, then negative. So now we have to see the working of this bridge rectifier. The load resistance Rm is connected across the diagonal PQ of the bridge. Here we get the output across this. The output is obtained across the load resistance. Rn. Let in positive half cycle of AC input the ends of secondary coil S, the ends A and B and B of secondary coil S are at positive and negative potential respectively. This terminal, this end is at positive potential, this is at negative potential. Then you see from here, this being the positive terminal, then this diode will be in the forward bias and D4 will be in the reverse bias, and the current will pass from P to Q. D2 being in the reverse bias, the current will not pass through it. And from Q to this diode D3, so D3 being in the forward bias, again the current will pass through it and it will go like this. So the current in the load resistance is from P to Q. The diode D1 and D3 are in forward bias, while diode D2 and D4 in reverse bias. It means that only D1 and D3 will impart the current. The diode D1 and D3 will conduct the current, which passes through load resistance from P to Q. This is the direction of current, P to Q. Now, when the current passes through this PQ, then output will be obtained at PQ. There is output across load resistance RF. This is what for the first positive half cycle. And then for negative half cycle, the polarity of the ends of the secondary coil will change. In negative half cycle, the polarity of the ends of secondary coil S changes. It means that the end A and B will be at negative and positive potential. Negative half cycle, the polarity of the ends of secondary coil changes, due to which diode D2 and D4 are in forward bias, and that of D1 and D3 in reverse bias. reverse bias. Then clearly the current will be due to this D2 and D4. There will be no current due to the diodes D1 and D3. The diode D2 and D4 will conduct the current which passes through load resistance RL from P to Q, and this process will be repeated. This process is repeated again and again and again. So this full wave is rectified. Thus in positive half cycle the diode D1 and D3 imparts the current and D2 and D4 diode D2, D4 remain inactive. While in negative half cycle of AC input, the diode D2 and D4 imparts the current and that of D1 and D3 are inactive. So the full wave is rectified. Full wave of AC input is rectified. And this is remembered that when the voltage is applied by the secondary coil, it should not exceed the Zener diode or the Zener voltage, because beyond this the diodes may be damaged. The precaution is taken that voltage in reverse bias voltage applied in reverse bias should not exceed the breakdown voltage. The breakdown voltage. Otherwise, the diodes may be damaged due to heat. This precaution is taken while we have whether we use this bridge rectifier or the simple rectifier. Then in both the cases, this is always remembered that in reverse bias, the voltage should not exceed the breakdown voltage. So this is about the bridge rectifier. Now we have studied both the half wave rectifier and full wave rectifier. So now I will tell you the comparison of half wave and full wave rectifier. Comparison of half wave and full wave rectifier. So now here we write down the half wave. Rectifier. Here the full wave rectifier. Now here we find the average. Average current. In half wave rectifier, this average current is equal to I naught upon 2, I naught upon pi, and this is equal to 2 I naught upon pi. Both are the positive, so we will add the other two. RMS current means this IRMS equal to I naught upon 2, and here this IRMS equal to I naught upon root 2, and here we have the number of diodes. Here only one diode. Here we have two diodes. And then the efficiency. Eta. Here the efficiency is 40.6%. This is now your 81.2%. Just double of this. So this is the comparison of the full wave and rectifier. Because of this one, if we are aiming to this, the value of this efficiency is being more. So this full wave rectifier is more useful than the half wave rectifier. Thus, full wave rectifier is better than half wave rectifier. So this is what the comparison of the half wave and the full wave rectifiers. So you all like and subscribe this video, and I tell you that right from 1st June 2021 I am going to start the online classes of 11th and 12th, and also the crash course of NEET Physics for 2021. So if you want to join me, please call me at the phone number that is given to here, that is your 70147 and 34805. Note: for online classes of physics, contact number 701473480534805. So you please contact to me, and thank you very much to all of you.